Hello again. In this lesson we're going to be combining like terms. So we see this long expression here, and what we're really doing is trying to just simplify it, make it a little bit more manageable. We're not trying to find an answer. The answer isn't 3. You can't even find an answer without knowing the value of x. So what we need to find is terms that have the same variable raised to the same power. Those are like terms, and we're going to combine them. So best to kind of just dive in and kind of look at some examples and see how this works. So all of these different terms, some of them can combine. So I'm going to look at this positive 3x and this positive 3x squared and minus x squared. Same variable, same exponent. That means we can combine them. How do we combine them? Look at the coefficients. We have a positive 3 and a negative 1. Positive 3, negative 1 gives us 2. Two what's 2x squared. If we had 3 apples and negative 1 apples, we'd have a total of 2 apples, negative 1 apples. But 2x squared is when we combine 3x squared and minus x. I've circled them. That's a good strategy. I'm going to put a square around the next terms. I see these terms both have x's with an exponent of 1. 2x's, negative 7x's. Combine the coefficients, negative 5x. What's left? We can underline these ones to kind of denote them. We have positive 5 and positive 10, both constants, gives us a positive 15. That's our final answer. We're not trying to go any further. We just simplified it a little bit. Let's just look at some more examples. This one's actually less complicated. Here we see a negative 3x and a negative 2x. They both have the same variable raised to the same power. Combine the coefficients, negative 3 and negative 2 is negative 5. Two constants, 5 and 4 is 9. Here I see a 3x squared. I don't see any other x squareds. So that's it. It doesn't combine with anything. I see a negative 2x and a positive 4x. So those can combine as positive 2x. Combine the coefficients. Negative 2 plus 4 is 2. Then we see a 5 and a 7 add together to give us 12. Let's jump down to a different example. Here we see we have different variables, an m, an n, and a p. So let's go ahead. I'm going to go in alphabetical order. So I'm going to start with the positive 8m here and a negative 10m there. Together, coefficients give us negative 2m. Let's move on to the n's next. So I see just one n, so it's positive 3n, and then p's. We have minus 5 and positive 2 is negative 3. Try to put a triangle around that, and we have 6 left as our constant. Here are some more advanced examples. When we have a product of variables in a couple different places, and at the end we have a product and one of them has a square on it. One other thing to note is that we have 3mn, and later we have negative 2nm. Because of the commutative property, we know that those are really the same. So I could rewrite those. It's still like terms. So I'm going to go ahead and start with a negative 6m and negative 6n squared m. That's the highest degree. So we're going to try to put this a little bit in standard form. Then I do see n squareds here, a positive n squared, and we see a negative 4n squared. So I'm going to put a box around those. And 1 and negative 4 is negative 3n squared. Then I see positive 3mn and a negative 2nm, same term, so that's really just mn, 1mn. Those are the only things. The rest of the terms here have nothing in common. Oops, I'm going to put those in standard form. Let's go ahead and put the m first alphabetically, then plus 5n and plus 1. With the remaining examples, we can try those in class.